The most exciting thing you can possibly do on Earth is to get away from it, jump in a rocket and blast into space. Rockets always seem to be firing us into the future, but their basic technology is rooted far in the past in firework-like missiles developed almost 800 years ago in 13th century. Since the first modern liquid-fueled rocket soared to the sky in 1926, rockets have ferried about 500 people, several thousand satellites, and quite a few unmanned probes to the deep darkness beyond Earth. While exploring space is obviously the main point of all that effort, it's worth remembering that stepping outside Earth gives us a better understanding of our own planet. Weather forecasting, climate research, and navigation are just three of the things we can do better thanks to the development of the space rockets. So, our first question is, where does space start? Most jet planes don't fly above 15 kilometers, where there's still enough oxygen to burn fuel in their engines and keep them flying, but that's nowhere near the start of space. Space is generally defined as starting at about 100 kilometers above Earth, an arbitrary point sometimes called the Kármán line, which is where conventional planes would struggle to make enough lift to stay in the air. That doesn't mean Earth's atmosphere is all done and dusted by that point, far from it. The lowest satellites, known as low Earth orbit, LEO, satellites, fly at heights above 160 kilometers or 100 miles from Earth, which is over 10 times higher than planes fly. Even so, they still feel some drag, aerodynamic resistance, from the outer reaches of our atmosphere, which fizzles on up to 800 kilometers. You might think space is a long way away, but 100 kilometers is not so far. A car, hurtling along at highway speed, would take just an hour to get you there. A rocket will get there about 20 times faster in just 3 minutes. What does space look like? From the point of someone designing a rocket, space is the place effectively beyond Earth's reach, beyond most of its gravity and atmosphere. Although we tend to think of it as a vacuum, it's not completely empty. There's radiation zipping through it. There must be, how else would we see all those distant stars and planets, meteorites nipping past, cosmic dust, and even bits of space junk, broken bits of satellites and rockets. Perhaps the best way to think of space is as a place of wild extremes, emptiness, weightlessness, when you're far from any planets. 1 minute, deep darkness and extreme cold, when you're shaded from the sun; the next, blinding light, dangerous cosmic radiation, and extreme heat. Is there more than one kind of space? Mostly we're interested in the interplanetary space of our own solar system, the area around the sun, which is measured in distances of millions of kilometers. But space telescopes and unmanned probes also study the further reaches of what's called interstellar space, the space between stars, measured in vastly greater distances called light years, the distance light travels in 1 year, which is almost 10 trillion kilometers. The Milky Way galaxy, of which our solar system is just one part, measures about 100,000 light years. What are black holes? A black hole is an astronomical object with a gravitational pull so strong that nothing, not even light, can escape it. A black hole's surface, called its event horizon, defines the boundary where the velocity needed to escape exceeds the speed of light, which is the speed limit of the cosmos. Matter and radiation fall in, but they can't get out. Two main classes of black holes have been extensively observed. Stellar mass black holes with 3 to dozens of times the Sun's mass are spread throughout our Milky Way galaxy, while supermassive monsters weighing 100,000 to billions of solar masses are found in the centers of most big galaxies, ours included. Astronomers had long suspected an in-between class called intermediate mass black holes, weighing 100 to more than 10,000 solar masses. Wormholes and time travel. Einstein, 1914, worried that his theory of relativity might allow for spacetimes with so-called closed time-like curves. Gödel, 1949, constructed a cosmological model where this phenomena can happen, however at the cost of an enormous amount of energy for the journey. More recently, renewed interest focused on the possibility of constructing such time machines with the help of wormholes. Wormholes are spacetimes with non-trivial topology in which a kind of tunnel exists connecting distant parts in the universe. These wormholes may not only serve as shortcuts in space but also for time travel. What is Kardashev scale and types of civilizations? At present time, humans are using 17.35 terawatts of energy that we use in factories, building houses, and cars. We are developing day by day and have an aim to terraform Mars. But we are not as developed as we think we are. In 1964, a Soviet astronomer Nikolai Kardashev developed a scale that measures the development of the universe that is known as Kardashev scale. This scale is based on the energy we used per year. According to Kardashev, there are possibilities of 3 types of civilization in the universe. Type 1 civilization have full control on their planet. They can able to change seasons, maps, and utilize 100% energy of sun. But it is nothing in front of Type 2 civilization. Type 2 civilization, also known as stellar civilization. This civilization have full control on their nearer star and use 100% energy. They are able to transform this energy to any part of their solar system. A model is made in which the energy radiating from sun is utilized. This model is known as the Dyson structure. You must have seen this structure in sci-fi movies. It is a network of satellite around the star that utilize 100% energy. Type 2 civilization has full control on all planets of their solar system. Robots, humanoid, virtual reality, electric planes, and quantum computer are developed. Type 3 civilization is also known as galactic civilization. This civilization is able to utilize the full energy of their galaxy. They are also use the energy of stars, but the difference is that this civilization does this with millions of stars and planets. This civilization use planets as cities. They use 310 times 1037 watts of energy. I know you are thinking, that is this possible? From my opinion, it is really possible because it doesn't break physics laws. One day humans may become masters of the galaxy. Please share your opinions in the comment box. Thank you for watching this video.